All right, so today's lesson is about finding the function transformations that will transform a sinusoidal parent function. We're going to be focusing on the amplitude, vertical shift, period, and phase shift. These will relate to a lot of the ideas that we saw last time to do with amplitude, midline, and period. So with a sinusoidal function, here's your basic ideas. We're going to start off without a phase shift. So it's going to be of the form A sine B theta plus D. So A is the amplitude transformation. Obviously, this is going to give us a vertical dilation. Now, the vertical dilation of factor absolute A. So if A is negative, we'll get a reflection, but the amplitude is simply going to be affected by the absolute value. So however large that is, that's going to give us that vertical dilation. If we have A less than 0, we'll get a reflection as well. Easiest one typically to find is D. D is our midline. So Y equals the midline, Y equals D. This is the vertical additive translation. So if we have a additive transformation vertically, we're going to be going up and down by D points. And then we have our horizontal dilation, which is the absolute value of 1 over B. We really don't want to be getting into negative values for this. That just seems a bit pointlessly difficult. But you can get them. It will work, and it'll just reflect it. Because it's periodic, there's no real good reason to reflect it. You just shift it across a bit. And the period is going to be the absolute value of 2 pi over b. But like I said, there's no good reason to have a negative b value. Right, let's try one out. So what we've got here is we can see a sinusoidal function. The amplitude is given as 6. We even get the period, it's been included here. So the period is included here, the amplitude is there, and we can see what the midline is. So once you know what these 3 values are, it isn't going to take much effort to sort of create a function that fits these values. So sorry, the midline's here. We want h of theta. Now the amplitude is going to be 6, so A is equal to 6. Our period is going to be pi, so we need the period. B is equal to 2 pi over the period. So that's going to be 2 pi over pi, so B is going to be equal to 2. So we're going to get 2 theta. And then the midline is going to be plus 3. So we have 2 multiplicative transformations. We have the vertical multiplicative transformation, 6, which is going to give a vertical dilation, factor 6. We have a horizontal horizontal multiplicative transformation, which is going to give a horizontal dilation. This one is going to be a factor 1/2. And then we have an additive vertical transformation, which is going to move it up by 3. All we've got on the horizontal transformations is the dilation. In this question here, we don't have a phase shift or a horizontal transformation. We will have them, but we leave them off because those are the hardest parts. So it's often we introduce these 3 constants first, get a feeling for them. They're quite easy. That one is a little bit trickier. All right. Have a go at finding an expression for this one. Like 2 minutes for this. Okay, so let's have a look now. The figure shows the graph of the trigonometric function. Write an expression for f. So we need to start off by finding the midline, finding the amplitude, and then finding the period. So we have some formulas that we can use. So the amplitude is given by A, which is always going to be the max minus the minimum over 2. Sorry, max plus the minimum over 2. It's the average sort of distance between these. No, it is minus. What am I doing? Yeah, it's the difference between them halved. So the maximum is going to be at 6. The minimum is going to be at 0. We are going to divide that by 2, and we can get 3. You can see it here in this graph. It's not a hard graph to find. Line up in this direction. It's quite clearly plus 3 from that point there. But sometimes it's a little harder to see, so it's good to have the formulas. The midline. The midline is equal to D. This one is going to be the average of the maximum and the minimum, which is going to be 6 plus 0 over 2, which is going to be 3 in this case. We can see it in this one. It's not difficult to see. It's going to give us this line here. We can see the midline in this case at y equal to 3. Our next one takes 2 steps. So we need to first find the period. The period, we need to find 2 particular x values, and then we need to find the difference between them. So depending where we're going to be working on, I often like to go for finding the x values at the maximum or at the minima. But in this particular case, they're not easily read. If you know where the midline is, because you don't always necessarily know where the midline is, but in this case, we do know where the midline is, and we can see the period quite easily here. This is one complete cycle. So in this case, we can see that the period is going to be pi minus 0, which gives us pi. This means that B is going to be 2 pi over the period, which is going to be 2. That's why the curve has been halved in length. It's going to give us a horizontal dilation of a half. Normally it would take us, we'd have 1 cycle in this graph here, but we have 2 full cycles because it's half as wide. It's had a horizontal dilation, which has caused by a factor of a half, which has caused a compression. And we can put up our answer now. So we're asked to write our expression for f of theta. So f of theta is going to equal, what have we got? It's going to be 3 sine 2 theta plus 3. Any questions on this one? Yeah, so for the period, what we need to do for the period is we need to find 2 good x values that we can read off of the graph. Normally I go for these 2 as our 2 x values to see 1 complete cycle. But the scaling of this one means that we're not quite sure, and that's a little tricky to read off. I choose those because on a drawn graph, they're distinct points. You can clearly see where the maximum is. You can't always see where the midline is until you've worked it out. But in this one, we do see the midline quite easily. So we're taking this coordinate here, which is at 0, 3, and we're taking this coordinate here, which is at pi, 3. They have the same y value. That's important. So then we look at the difference between the x values. And that's what we do here. And we find the difference between the x values, which is pi. Okay, so then the b is 2 pi divided by the period. Okay, have a go at this question. Discuss with your table partners. 1 minute for this one. Okay, so for this one, we need to determine what the period and the amplitude is. We can see here in the graph, the midline is going through here. We can see the period is going to be pi. and we can see that the amplitude is going to be 2. So this is 2, this is pi. So I think the correct answer is going to be A. This is going to be y equals 2 sine. Oh, not quite. Okay. This is going to be minus 2 sine 2 theta minus 1. This is the function if you wish to know. Have a go with this question now. All right, yeah, sorry. Yeah, notice that we have a reflection in this one. So the normal sine function starts by going up like this and then like that. So clearly this one has been reflected. So I put in a minus there for that one. You can actually make this with other functions. There's other possibilities you can do. So you can make it with a sine curve and a horizontal shift. You can actually shift it across, but we'll see that later. It's not the only correct answer, that one. Have a go with this one. Okay, so we have 2 points. I generally recommend doing a little bit of a sketch to help you with these type of questions. We have our sketch like this. So we have a sine function looking something like this. Oh, that didn't work. We have a sine function looking something like this. We've given some information. This is going through 0, 6. And then we have a minimum occurring straight after that one at pi over 2, minus 4. The graph looks like this. What we want to do is we want to find the amplitude. So A is going to be max minus min over 2. And that is going to be 6 plus 4 over 2, which is going to give us 5. Our midline is going to be max plus minimum over 2, which is going to be 6 minus 4 over 2, which is going to be minus 2 over 2, which is equal to, it's going to be not minus 2, it's going to be 2 over 2, which is at 1. And then our period. Our period, we can't quite see. So what we have here is we know this distance here, and this distance here is half the period. So we can say that half the period is going to be, what are the x values? Pi over 2. So if half the period is pi over 2, that means that the period is going to be pi, and b is going to be 2 pi divided by the period, so it's going to be 2. So we've got 5, 1, and 2. That is this one. Oh no, missed this one here. Okay, have a go at this question. Where are we up to? Okay, so we have to guess which one of these is going to be that graph there, given there. So we've got, go for the easy bit first. We've got a midline of minus 1. So that means we can cross off this one. This has a midline of 1. The other ones have a midline that we are after. So next up, we need an amplitude of 3. So it's going to go from minus 4 up to 2. So B does, C does, and D does. Okay, so that wasn't much help. Next, we need a period of pi. So we need to repeat from here up to pi. Nope, not this one. So this one goes from here. Yep, that one works. So this one's good. What about this one? Just check. No, that one's pi over 2. So it's going to be C. Okay, we're going to look at the phase shift now. This gives us a horizontal translation. So it's an additive transformation. The trick with this one is here. Notice how we're going to subtract the phase shift to the right first. So if C is a positive value, x minus C is going to move us to the right C points or C units. If that bracket gets expanded, then the value of C will change. It'll be B times C that we might see, and that can be confusing. So that's where the confusion comes from a little bit. So for a phase shift, we need to move C units to the right. So have a go at example 6 now. Have a go at example 6 and see which one you think it is. All right. So what we're looking for is we're looking to see where. Let's start off by finding. What should we start? Let's find the midline. Let's find the amplitude of this one. So just doing it off of here, we can see that our midline is going to be there at -1. Our amplitude is going to be 1, 2, 3. So we're going to go up by 3 here. Now, the phase shift. This. Let's just check the period. So our period this time, this is going to be from here to here. This is at pi, this is at 3 pi, so our period is 2 pi, which means our value of B is going to be 1. So that means it's not this one. I'm not looking to see the minus sign in front of the 3 because we can phase shift it both ways. What we need to do is we need to move this across by pi. So okay, so just finishing this one off. This one's a little bit tricky because there isn't the right value that we need here in this one. This is going to be a translation of pi over 2. So we would need something of the type y equals 3 sine x minus pi over 2 minus 1. Now that's not there. It's not one of the choices. So let's imagine that this is the curve that we're after here. Oh, silly me. Let's imagine that this is the curve that we're after. So in this case, we are going to want a different curve, which would be -3 sine. And then we're going to need to move across to this particular point there, which is 3 pi over 2. So if we phase shift across by -3 pi over 2 minus 1, these two functions here are the same function, different forms of the same function.
Isn't it plus pi over 2 for the first one?
And that is going to give us this one here. Look. So that one is going to be there. Okay. That one was a tricky one. That one was a tricky one. Okay, just picking this one up again, what we notice here is this one here is a cosine function. So this one is almost right. What we would need to do for the cosine function is we would need to move this across here by pi. So this would give us minus pi. So this function, if it wanted to be as a cosine function, would be 3 cosine x minus pi minus 1. If we look at b, that's a reflection. That's a reflection of that one. So we can get there with a cosine and with a reflection. In that case, there's a couple of ways to do it. What we would be doing is we would be moving this point backwards, or we just don't move it across and just start by reflecting it straight off here at this point. So we could say y is minus 3 cosine of x minus 1. And then this one's going to work for us. Okay, so our last question then. Oh no, it's not. We got 2. Let's have a look at this one. Have a go with this one, see if we can work out what the answer is. Okay, so we've got first off here, we've got 2 choices. We've got cosine functions and sine functions. Now, if it's a cosine function, we need to move this point across. If it's a cosine without a reflection, we need to move this point across by a half. So it would be x minus pi over 2. If it's a cosine function without a reflection, we need that. If it's a cosine function with a reflection, then we would have a negative value at the front and simply no phase shift on this one. So with the 2 cosine functions, we do not have minus pi over 2. We don't have a reflection, so it can't be these 2. So with a sine function, then we need to move this point across here. So a sine function without a reflection, this is going to have an x minus pi over 4. If it's a sine function with a reflection, then that's going to come all the way across like this. Let me do that in a different place. That's going to come all the way across to here and then reflected down at that point. So that one's going to be x minus 3 pi over 4. And then we're going to have a reflection as well. We're going to have a minus a. This one's going to have a minus a. So we need minus 1/4 pi or minus 3/4 pi. We got minus 1/4 pi. So it should be C here on this one. Let's just check the other bits and pieces. Our amplitude is going to be 2. Our midline is there at y is equal to 1. And our period, so we go from here to here is pi. Our period is equal to pi. So B is equal to 2. This here at C is the correct answer there. This is the correct answer. Now watch this. Watch this. One of the things that can trick you with these ones is this is also 2 sine 2x minus pi over 4. Sorry, minus pi over 2. Has this been shifted pi over 2 to the right? It hasn't. It hasn't, because I've expanded that bracket. So when it comes to seeing the phase shift, it has to be factored on the inside. You have to factor out the b. So we are always looking at to be of the form a sine b bracket x minus c close bracket plus d. Now that is equal to a sine bx minus bc plus d. So bc is pi over 2 when b is 2 and c is pi over 4. So take care when they're shown in this format, you won't see the phase shift as easily until you factor the inner bracket, factor out the b from that one. Last question for us today, have a go at this one, have a go at finding the function. This will take us 5 minutes for this one, it takes a little bit longer. Let's have a look at this. All right, so very important this one. This is for FRQ3 that we're going to practice. What I would suggest doing is just putting in your coordinates here. I like to see them in the graph. This is 2, 16. This is 5, 11. Where are we? 8, 6. K, this is 11, 11. And P, this is 14, 16. Now, we need to find the different values. So one of the easiest things for us to see is we can see the amplitude here. The amplitude, it's going from 11 up to 16. So that's gone up by 5. So the amplitude here is 5. We can see the midline is the line y equals 11. And then we need to figure out our period. Our period is this distance across here. So this is a period of 10. Sorry, it's 12. This is a period of 12. This implies that B, sorry, I'll do it down at the bottom. So from those bits and pieces, we can work out our information. Amplitude is equal to 5, that's A. Our midline, D is going to be 11. Our B is going to be 2 pi divided by the period. So this is going to be pi over 6. Now lastly, probably the easiest way here on this one is we're going to do this as a sine function. Note whether we're going to do it as a sine function or a cosine function. A sine function starts off by going up. So we can take our sine function and we can take one full period here like this. So we start off there. So that means we can write this as that D, one possibility for D is that, I'm writing in red, is that D is equal to 11. Oh, sorry, C. C is equal to 11. But no, wait. Let me just check this one. Notice the format they're giving here. They haven't got a negative there. They're not saying T minus C. So the C has to carry the negative as well. So in this case, C is going to be minus 11. We need to go across to the right by 11. Sorry, did I? No, 11. Sorry, what was your question? Yes. So what I'm doing is we need to shift this coordinate across. This coordinate should be at 0, 0. We need to move across. We move up by 11 and we move across by 11. So D is equal to 11 and C is equal to minus 11.
But shouldn't it be at -1?
No. So, however, remember that if this is at 11, where is this point here? There, you're getting it now? So we can have another period. We've got a period here of 12. So if there's 12 between these ones, then this one could be at -1, 11. In fact, the value of D is going to be this value plus n periods. So we can add and subtract n periods to whatever the C value is and we can move it across and we'll still get the same graph. Because I'm starting over here at K, you could just as easily start off over here with your graph there. Or you could start it here at this point and draw that one and have your C value given by this point, which would be at 23. This would be at 23, 11. So any of these can be used for your C value. So this point here would be at -1. So we could have C is equal to 1, C is equal to -11, C is equal to -23. So C is equal to -11 plus n, let's say 12n, because the period is 12 this time.
For this example, there doesn't have to be a translation.
There does have to be a horizontal translation for this one.
Well, it's still correct if there isn't.
No, it's not. It has to fit this model where n is an integer. So possible answers would be -11, +1, minus -23, or 13.
So does multiplying by the b value change anything?
The b value will change it if it's not in factored form. But in this case, it's factored, so the b value isn't going to change it. Isn't going to change the value of c. It would be if you expand the bracket, and then you'll get different looking periods. All right, that's it for today. We're going to have a go at the classwork now.